So I am presenting my final for CS732. My project was a Kaggle submission for the Santander customer satisfaction data. I will be doing a comparison of random forests classifier and the XGBoost classifier, and I implemented them using the scikit tools, and then additionally I implemented the random forests algorithm for learning purposes, but for the sake of this presentation we can assume that I used the Python scikit toolset. So what is Kaggle? So Kaggle is a really neat site. If you haven't heard of it, you should definitely check it out. It's got a lot of cool stuff on there, but it's right now the largest online community for data scientists. So they host competitions or just anyone that wants to get involved with complex data science problems, as well as they have data sets on there for learning or just advancing the science as a whole. It's pretty cool. So what is the competition that I did? So Santander Bank submitted a contest on this site, on this Kaggle site, to help them identify which customers of theirs are satisfied versus satisfied. So the Santander Bank provided a training data set and a test data set, and our goal is to clarify whether or not, given the test data set, we can predict whether or not a customer would be satisfied or unsatisfied. So just so you guys can see here, I'm actually going to run the algorithm. I'm going to get it started here because it takes a little while, just so you can see it actually happen in real time. So continue what I was saying. So each Kaggle is given the data set, and then they're asked to predict. The data that was provided included 368 numeric variables. It also included about 75,000 rows of training data and about 75,000 rows of test data. So the idea is you train whatever other algorithm you design with the training data, and then you test with their test data, and you produce a submission file which contains your prediction for the classification. So in this case, it's either going to be satisfied or unsatisfied. So what's my strategy overall here? So first we're going to transform the data they gave us into something that we can use for the algorithms, and then we're going to actually apply random forests and XGBoost, and then we're going to compare the two results and see which one worked out better. So for transforming the data, I used a library called NumPy. Didn't have to do much work, we just had to get it into a format that the classifiers could consume. So let's start with the random forest classifier. What is it? It's a divide and conquer approach to classifying, which involves many decision trees. So the idea is you have many decision trees and you aggregate all these results at the prediction time. And so the number of trees that you use in this random forest are determined by the user completely experimentally or statically, not dynamically. Algorithm is essentially we create all the decision trees that are requested, and for each of them we allocate a random subset of the data set selected with replacement, so that each decision tree is trained with overlapping data. Then we begin traversing the tree, just like a regular decision tree. At each node, we look for a variable which will optimize the split, and we continue to train the tree. This is just a diagram explaining that. You can see we take all the data and we distribute it randomly amongst the number of trees that you specified. In the case of our experiment, we use 300. And then you can see at each node, you choose some subset of variables, and you try and optimize the split as you go. The pros are that, random forest, let's say we have categorical data, and we're missing some values that we don't know yet. This will work really great for that. Just basically, you don't need to know all the data up front. can handle outliers, and you also don't have to make any distribution assumptions. Because of this, there's high variation. The trees are not as stable because they're maybe changing as data flows in, but for this reason also they're prone to overfitting if the aggregation is not done properly. So now let's talk about XGBoost. What is it? Extreme gradient boosting. So gradient boosting is based on the concept of weak learners. So this means, in our case, decision trees that are very shallow. And the way this works is we start with an initial decision tree, and we look at the error that was produced based on what the training data says and what the target was, and we use the error to predict the next tree. So how this works is we sequentially iterate the data set, and we limit the size of the trees to be, in our case, 3 nodes, but generally speaking, very small. At each step, you compute the error and use these derivations to then predict. And this is where the boosting comes in. So we're using the errors to predict the next tree, and therefore, because we're predicting the preceding tree, we're kind of boosting the errors forward. So it looks like the algorithm is finished. We'll get to what that means in a second. This is just another way to visualize what I just said. You can see at each node, we're kind of doing a training step based on focusing on where the errors were. This is another way to visualize it. So if you look at starting at the top left, you can see we started with the data, and the first second bottom left is the second step. This is where we chose a simple thresholding, so not as complex. You see it doesn't fit the data there, and as we progress top right and then to the bottom, you can see those would be kind of representative of adding decision trees. We are making a more complex curve, which will ultimately end up fitting the data better. Pros, it's fast. XGBoost is even faster than gradient boosting, and gradient boosting in general are better learners over time. So this means with each tree added, the model becomes more expressive and better at predicting. The cons is just that it runs sequentially and it's harder to parallelize as compared to the random forests. So the results. So how do we judge kind of success? So the competition, Kaggle in general, most commonly uses this metric called AUC, area under curve. And so in our case, when you have a binary classification problem, satisfied versus unsatisfied, we're looking for a AUC score of close to 1. And the reason is, if we consider a plot of true positives to false positives, we're going to want the true positives, where we guessed correct, that is, to be at a rate which is closer to 1. If we were to just random guess, that'd be closer to half. So 0 is bad, 1 is better. Estimating our score, because we're not submitting the score or submitting the results yet, we are going to estimate by taking a portion of the training data. So for the purposes of testing, we would withhold 20% of the training data. So if you imagine the 75,000 records we had of training data, we have the end result, we have the target. So we arbitrarily withheld 20% and then use this to test our results. And this is how we came up with the scores that we have here. So comparing the two with some cross-validation that was done about 10 times for each, you can see we ran, and these are the averages. I'll show you the actual results in a second from the last run I just did, but you can see XGBoost is a little better, higher score, and this actually lines up with a paper that was published comparing the two algorithms. Over 51 data sets, XGBoost averaged a higher score, which is why it's kind of the default for Kaggle competitions. And generally, it's like the baseline score if you were to go and look at that. If you want to see more of my work, you can see kind of the exact code that I published here for the competition. Also, you can see my implementation of random forest as well. This is the program that I ran. So this right here on the right is my implementation using the scikit tools. So you'll see down here we have a main method, run XGBoost and run random forest. Generally, what this code is doing is reading from a training file. That's the 75,000 training data records and the test data. And you'll see here variable number 370 was the target, and that was the Boolean 0 or 1, 0 being satisfied, 1 being unsatisfied. And so we filter out all the target variables from the training data, and then we use that to classify our random forests. Down here you can see we do the same thing for the XGBoost algorithm. And long story short, the results of that are here. So this is the Python package that I just ran, and you can see here the XGBoost score was 8.83, 0.84 roughly, and the random forest score was 0.79. That's all I have. If you have any questions, you can send me an email at dc28. Thanks.